Imagine the flexibility of being able to access authentic, relevant training anywhere, anytime, with or without an active internet connection. Advances in mobile learning technologies enable the workforce to get the right amount of training at just the right time. Recently, the FAA partnered with ISC Federal and Utah Valley University to develop a proof of concept which demonstrates many of these advanced technologies as a viable alternative to the way the FAA currently provides training. Using a mobile platform, trainees can access lessons directly from their favorite personal or government-issued device. By supporting major devices such as Windows, Macintosh, Android, and iOS, trainees can use a system they are already familiar with rather than needing to purchase and learn a new platform. Trainees are automatically notified once course administrators assign course materials to their classes. A simple click or tap can download content to the learner's local device for both online and offline use. Learners view their available training courses through an attractive book motif or library. The use of industry-standard security and privacy protection components, such as AES encryption, secure socket layer, and mandatory account authentication procedures, are important to keep training materials safe from eavesdroppers. The right instructional design is the difference between a simple collection of study aids and relevant, comprehensive training that enables learners to perform job tasks. An outcome-based approach is key to developing relevant training. This focus on what the trainee needs to be able to do begins with a comprehensive analysis of job tasks and the current state of training prior to course design. At the beginning of each training component, trainees are provided the rationale and motivation for learning. A clean, minimal, visually appealing layout ensures that learners experience familiar textual content navigated by standard hyperlinks, referencing select portions of the course. In addition to standard note-taking and highlighting capabilities, the platform allows FAA trainees to attach questions to blocks of text. These questions are then sent to instructors or classmates in context with the relevant course material. As answers appear, learning groups experience a better correlation between content, questions, and answers, enabling trainees to ask and answer questions in context with related materials, expand static learning into a collaborative and crowdsourced experience, providing learners with an inherent study group of their peers. The focus plus context layout of course material allows learners to study concepts in relation to other concepts or to zoom in to see greater detail. As an example, clicking on images or videos expands them to full screen mode for improved visual detail. The platform incorporates HTML5 exercises for online and offline interaction, interacting with components and virtually practicing what they will do in the field. Trainees gain familiarity and confidence through experiential learning. Here, each component is linked within the NIDS control cabinet to more detailed information that is linked back to the corresponding FAA documentation. Learners are able to interact with the NIDS control cabinet components within the first few minutes of the training course. Through engaging activities, trainees learn the steps and sequence of installing this network from scratch. When mistakes are made, the activity can correct the trainee and offer learning hints. In this scenario, learners select and connect the appropriate network components to install a full NIDS cabinet. Upon completion, learners will have experienced the setup of the NIDS cabinet from start to finish, in preparation for hands-on access to the operational equipment. Since work is done at a trainee's own pace, advanced learners can progress more quickly, while others may revisit the activity until mastery is achieved. The activities also provide the learner opportunities to receive immediate, formative feedback, which promotes comprehension and corrects misunderstanding prior to final assessment. One of the most important responsibilities of technicians is troubleshooting. This branching activity allows technicians to practice and access their ability to troubleshoot a portion of the NIDS software. This activity and other legacy training materials may be imported using SCORM or the more contemporary XAPI. Software system interfaces can also be built to enable connections to existing learning content management systems. Video promotes training standardization through consistent delivery. Trainees may replay content during training or even use approved job aids on demand. The use of motion graphics and animation is an effective way for learners to visualize complex relationships. How-to videos provide real-world examples and instill confidence as learners observe tasks being performed. Interactive 3D models can be a particularly effective learning tool in technical and complex relation areas where distinct components function as a part of a larger system. 3D models allow the learner to virtually dissect systems, support interaction and experimentation, and can even be used to transport individuals virtually into an environment that could be costly or difficult to reproduce. As trainees complete individual training activities or modules, assessments are provided to verify learners' progress and understanding. These assessments are immediate, interactive, and secure. Test questions may take the form of multiple choice, true-false, fill-in-the-blank, short-long answer, matching, picture selection, and other question structure paradigms. Trainee answers can be immediately recorded on cloud servers or buffered for later transmission depending on whether the learner is online or off. Regardless of internet connection, trainees will receive immediate feedback on test results or other activities. This helps learners determine whether they need to revisit a given learning module or whether they are prepared to advance to the next section. Through each step of the training course, analytic information is gathered for each trainee. In the corresponding assessment page, a variety of these analytics are displayed. The size of the quiz question bubble denotes the relative time spent on each question. Numbers display the percentage of correctly selected options for each question. Visual display patterns can alert instructors to erroneous questions or potential issues in learning content. Identifying such patterns as early as possible facilitates a better learning environment with more satisfied trainees and instructors. A virtual learning lab can support the use of advanced course material. Third-party apps may also be incorporated to provide additional content and features for a seamless learning experience. Going well beyond the functionality provided in traditional ebooks, the Proof of Concept platform allows for virtual and augmented reality experiences. A virtual environment enables students to explore locations and surroundings using a 3D perspective. Using the tablet's accelerometers, students are able to navigate through a 3D environment. The augmented reality viewer enables students to use their device's camera to scan for predefined real-world objects. When such target objects are encountered, the tablet overlays relevant information such as installation steps, directions for troubleshooting, or a 3D virtual representation of the object in question. 3D environments present training within the context of associated job tasks and provide simulated opportunities to interact with virtual system components. In this scenario, trainees must replace two faulty network surge protector modules. Within their respective virtual environments, concurrent learners may perform interactive activities, which enables them to experience systems without the costs associated with real-world facilities. Such part-task training activities provide the learner with valuable spatial relationships, task sequencing, and diagnostic experience. The ability to access authentic, relevant training anywhere, anytime, provides opportunities to improve training quality. This ensures that the workforce receives the right amount of training at just the right time.